Alright, so in this set of equations, we're going to use our third conversion factor because we're going to be going from mass to our number of molecules. So in this case, we can use this third situation where we've got Avogadro's number of molecules per the molar mass in grams, since they are equivalent quantities. So that's the conversion factor that we'll use for these types of equations. So if we've got a question that says, how many molecules are in 6.2 grams of water? We know we can use our mass to number of molecules conversion for this question. So we want number of molecules. So that's what we want to get to. And we're going to start with our 6.2 grams. So we know we need our conversion factor. So do we want molecules or grams on top? We want to get molecules, so we want number of molecules to be on top. And we know the molecules are 6.02 times 10 to the 23rd molecules in essentially the molar mass of our compound. So for this one, since we've got mass again, we have to calculate molar masses. So we're going to need to calculate the molar mass of our water molecule. So we know that is 2 times 1, since the mass of hydrogen is 1, plus 16, or this is going to equal 18 grams. So we can put our 18 grams here on the bottom. And we can do this calculation, and we will end up with the number of molecules in 6.2 grams of our substance. So we end up with our answer as 2.07 times 10 to the 23rd molecules of water. So our answer, 2.07 times 10 to the 23rd molecules of water in 6.2 grams. So we can do this going the reverse direction as well. So in this case, we want to know how many grams. So grams is what we're going to want to end up with. We start with our number of molecules, and we're going to use this same type of conversion factor here, except our molar mass has to go on top this time. So we're going to put our molar mass in grams on top, and the number of molecules on the bottom, because that's what we want to cancel out. So remember, we're not going to use 18 grams this time, right? Because our molecule is different. Our molecule in this case is nitrogen gas. So we've got to calculate the molar mass for nitrogen gas, which is going to be 2 times 14, or that's going to equal 28 grams in the case of nitrogen gas. So we put the formula weight or the molar mass up on the top here. So we've got 28 grams are in 6.02 times 10 to the 23rd molecules. When we calculate this out, we're going to see our molecules are going to cancel. So we had grams cancel in the upper equation. Molecules are going to cancel out here, and we'll be left with our answer in grams, which is what we want. So let's go ahead and calculate this one out. So when I calculated this out, my calculator told me this is 14.8 grams of nitrogen gas. And does that make sense? We've got almost half of 6.02 times 10 to the 23rd. So we expect that to be very close to half the gram weight, which it is. So that would be a good check for our math problem there. So this is the way you can use our third conversion factor to calculate different types of problems. You just have to look and see if you're going from mass to molecules, or whether you're going from mass to moles, or from moles to molecules, and that'll help you determine which conversion factor you're going to need to use.